The 1.3 lecture deals with two topics, basically range and domain, that are very important. So we start off by looking at a picture of a graph, kind of an upside down parabola. You'll notice they're asking us for the domain of f, so this function. And basically what you see is that the graph stops here and it stops here. So domain deals with x's or inputs. So we want to know how far the graph moves to the sides. And so in this case, it goes to the left to -1, and it goes to the right all the way to 4. Now this is a closed dot, so we put a square bracket around that. And this one over here is an open dot, so it gets a parentheses. So -1 to 4 is the domain. Then we simply are asked to plug in -1. Well, if I go -1 and follow it down to there, the output is right here. That's an output of -5. Same thing with 2. Here's 2. I follow it all the way up. There's my output, 4. So you should be able to tell inputs and outputs from looking at a graph. Now the range, those go with y values. So the range deals with the y. How far up does your graph go? How far down does the graph go? And you can see it's here and here. So it starts at the bottom. Always report the bottom first. So it starts at -5, goes all the way up to 4. And both of these get a square bracket because the graph touches it. Now you'll want to get out your graphing calculators and follow along. So in this next one, we're going to graph the square root of 9 minus x squared. So we're going to do the square root of 9 minus x squared. So what you'll see is we have a little bit of a semicircle here, the top part of a circle. Not sure what's happening here or here, but we're going to take a look now a little bit closer. So looking at the calculator, it looked like -3 to 3, and it looked like it went up to 0, 3. And that's actually what's happening here. So when you plug in -3 or 3, you get 0, which is the square root of 0. So that will work. So when you talk about the domain, it does go all the way to the left to hit -3, and it will actually touch 3 on the other side. And then the range, we can see that it does start at a y value of 0 and go up to 3 and touch that. So we go to the calculator again, and we're going to do x minus 9 under the radical. So this time, we do the square root of x minus 9. And what you can see is that it's barely on the graph. So I may go to my window and just extend this window to maybe 15, just a little further to the right. And so what you can see is this square root graph. So it's somewhere over here and just kind of goes up, and it is increasing. So what we're going to do is look at the domain, starts at +9 and goes to infinity. And the range will start at 0 and go up to infinity. Those are the y values, how far up and how far down. It's really slow, but it does go up forever. The algebraically piece means that when you deal with an even root, we want to make sure what's under the radical, which is x minus 9, is always greater than or equal to 0. So simply adding 9 to both sides will give us x's that are greater than or equal to 9. Same thing that this domain is saying. So the last part of this the last part of this problem will be determining where it's increasing or decreasing. And so what I like to do is go ahead and look left to right what's happening. So we're going to go left to right on the x-axis. So negative infinity all the way over here to infinity. And what you'll notice is this thing is always going up. So we would say it's increasing from negative infinity to infinity. A lot of students think it's getting flat there or constant, but if you plug a number like 1/2 and cube it, and then you do something like 1/8 and cube it, you'll see that the x's and y's are producing different outputs. Now here they're marking everything for us, so if I do negative infinity to -1 and 1 to infinity, working left to right, I could pick an x that's about right here, and its output would be down here. And if I pick this x, its output is up here. So you can see that it's increasing. So it's increasing from negative infinity to -1, and it's doing it again over here. You can see that the graph is going up from 1 to infinity. The decreasing portion of this graph is between -1 and 1. So as I go in this area, you can see that the dots are traveling downward. And the last part, increasing, decreasing, or constant, we can see that this graph is constant between 0 and 2. It'll be increasing from negative infinity to the 0. We always report the x value, so from negative infinity to 0, what part of the domain is increasing, and then decreasing out here from the 2 all the way out to infinity. You can see that the dots would be going down. So we say 2 to infinity. And also I don't use square brackets on any of these because square brackets means it's included and it can't be both increasing or decreasing. So keep that in mind, only parentheses. On this next page of notes, we're going to go ahead and find the relative max or min. So on an example like this, we have one minimum here, this is a maximum, this is a minimum, this is a maximum. Those are interesting points in mathematics. So what we're going to do is go ahead and type this function into our graphing calculator. So it's -x cubed, so I need to raise that to the third power, then get out of your exponent, plus 2x plus 3. So I look at this graph, this is what we're looking at. This is the maximum, it's going to go to infinity. This is the minimum, it's going to go to negative infinity. But this would be like in sales. If I charge too much money for a product, not many people buy it. So if I decrease the price, more people buy it. We want to find that sweet spot between charging enough that I'm really increasing my profits, but not charging too much that I ruin my sales. So that's why these are called relative mins and maxes, and they're more interesting when we look at mathematical formulas or formulas that we might use in a business class. So we go second, trace, which brings me into the calculate menu. We're going to do a minimum first. So I'm going to hit number 3. We're going to look for the minimum. Now it's telling me to get on the left side of my minimum, and my cursor is way over here. So I'm going to have to hit this quite a bit to bounce it to the other side here. We got to get to the other side of the minimum. And there we are. We're on the others. I'm on the left of the minimum. So now I hit enter. Then I go to the right. Now I'm pretty close there, so I want to get away from the bottom, a couple clicks. That's good enough. Hit enter. When it says guess, you hit enter. So my minimum is located at about -0.8. The output is 1.9, but the minimum is located at an x value of negative 1.8. Now to do the minimum was. So the maximum now, we go second trace again. And this time I say number 4, the maximum. I'm on the left, hit enter. Go and get to the right-hand side of this. Went way too far. That's far enough there. So hit enter, and then hit enter again. So this is 0.8. So we had negative 0.8 and 0.8. The graph would be increasing there. Everywhere else it's decreasing. So the next thing we're looking at is what's called a step function. It is the greatest integer function, not to be confused with rounding, because if I do 2.1 in this greatest integer function, it's a 2. If I did 2.5, it would be a 2. And if I did a 2.9, it would be a 2. If you don't reach the next integer, you actually slide back. And then the other thing you want to watch for is on a number line, here's 0. So here's negative 1, here's negative 2. If you do not reach the one on the right, you actually slide back to the one on the left. So pause the video now and plug in your answers for A, B, C, and D, and then I'll come back and check them with you. So here are the answers I got. 2.5, we said slides back to 2. Negative 2 is right on negative 2, so it's going to stay there. Now negative 1, remember, negative 0.4, remember, is going to be right in this area. Over here, negative 0.4. So you haven't quite reached 0, so you actually slide backwards, and that's why that one turned out to be a 1, negative 1. And then 1/4 is the same as 0.25, so you haven't reached 1, you actually slide back to 0. So now we're looking at a couple piecewise graphs. I'll do one with you. I think the easiest is to go ahead and make a table of values. So I'll carefully underline. I'll talk about this one in red and this one in blue. Now remember, these are the rules over here. So example, the other day we talked about if I do f of 4, I would say 4 is bigger than 1. So I would put this into the red function. 4 is bigger than the negative 1. So I would have something like 4 squared plus 2. So I would get an answer of 18. So it's a piecewise function. You only get one output. So the easiest way is probably to take the red equation and make an XY table. The first one I would start with is negative 1. Then I'd go to 0. Then I'd go to 1. Then I'd go to 2. I want to use numbers that are bigger than negative 1. So if I plug in negative 1, I say negative 1 squared is 1 plus 2 is 3. So I'm going to go to negative 1 and go up 3. Put my dot. Then the next one is a 0. So put in 0 squared, I get a 2. So when x is 0, I get 2. And when I put in 1 again, 1 squared is 1 plus 2 is 3. So I go 1 to the right and up 3. Now I know this is a parabola because of the x squared, so I can go ahead and draw the right-hand side of the parabola. The second part is a linear function, so I make another xy table. And I'm going to start at negative 1 and only do numbers that are smaller than negative 1. So negative 2, negative 3. When I plug in negative 1, I do the negative of negative 1 minus 3. So that's going to end up being negative 2. So negative 1, negative 2. Now I'm not supposed to use that, so I put an open dot. Then when I put in negative 2, I do negative of a negative 2 is 2 minus 1 is, or minus 3 is negative 1. So that'd be there, and then maybe one more dot. Negative over negative 3 is 3, minus 3 is 0. Because this is linear, I know I can just go ahead and draw it through those 3 dots, and there it is. So what I'd like you to do now is pause the video, try the DIY, and then come back and check your answer. So I did the piecewise graph, should look something like this. The red one, I made a table of values, plugging in even numbers is nice. Notice it's a closed dot when I start with my 2 and up to the right. This middle part is always 2 for inputs that are negative 5 to 2. So the negative 5 gets a closed dot. The 2 comma 5 gets an open dot. And then the green equation, putting in multiples of 5. So negative 5 is where it starts. Do negative 10. Those will give you nice outputs. And we put those in at negative 5, 4. You're going to have an open dot because you're really not supposed to use it there. And then it's out to the left. The final examples would be talking about odd or even functions. Simply, if you can fold along this line, you're going to have what's called an even function. So if you can fold right here and that side lands on that side, it's an even function. This part would be what I call a 180-degree spin. If you can spin it or rotate it 180 degrees like this and it lands over there, you have what is called an odd function. Those are the only two things, even or odd. The symmetry on the x-axis will not do anything for us, and so that would be neither. So you won't get odd or even in that situation.